Hello everyone, I'm Sunshine from 2EG. I will be briefly talking about what is ERT. Andrei Nikolaevich Tikhonov is known as father of ERT. He explained in detail how the ERT works based in the simple case of two-layer medium. It is used now to measure the resistivity. To define ERT means electrical resistivity tomography, which is used for imaging the subsurface structure from the resistivity measured on the surface through electrodes. ERT works based on the principle of conductivity and resistivity. The current is induced into the ground by the help of two current electrodes, and the corresponding voltage drop is measured by the two other potential electrodes. There are various applications of ERT. To list down its application, ERT is used now to study the soil lithology. Secondly, it is used now to map the bedrock depth and geometry. Thirdly, it is used for groundwater level investigation. And lastly, it is used in order to determine the variation in soil saturation and fault zones.
This is overall setup of ERT. Here current electrode AV are placed at the extreme points and potential electrode M and N are placed between the current electrode. Electrode array configuration consists of Wiener, dipole, and Schlumberger. In Wiener array, two current electrodes are placed at extreme point and potential electrodes are placed between them. In this case, the spacing between the electrodes are same. In dipole array configuration, two current electrodes are placed one after another and potential electrodes are also placed one after another, and also the distance between the two current electrodes and potential electrodes are same. Lastly, in case of Schlumberger array configuration, two current electrodes are placed at extreme point and potential electrodes are placed between them, and in this case the spacing between the electrodes are not same. After getting the resistance, we can calculate the resistivity by multiplying the resistance with the geometric factor. And in case of Wiener array, geometric factor K is equal to 2 pi A. Now rho equal to K times R, where the K is equal to 2 pi A and rho become the 2 pi A times R. Number of measurement can be calculated using the formula n equal to T minus 3A divided by A plus 1, where n is equal to number of measurement and T is total length and A is electrode spacing between them. Here we have one example we have solved, and measurement should be continue solved till the n value becomes negative.
With the continuation of my friends, now I am going to explain on the working procedure of how ERT works. This is an overview setup of ERT. Here we can see a system, three sets of energizer, battery and the connecting wires. And there are two current electrodes A and B placed at an extreme position and two potential electrodes M and N placed in between the current electrodes. Now I am going to explain the procedures. Firstly, connect the three energizer and the main system with the connecting wires. Then battery is connected to one of the energizer. Now input the method, array type and number of measurement in GERMI software and then upload into the ERT mesh. This process has been further explained in the latter part. Then measure the distance you want to perform the ERT. Using measuring tape and line should be aligned into 180 degree with the help of a suitable compass. So that the four electrodes are driven into the ground from one end in reference to the Venus method. Here electrodes should be driven into the ground with an equal interval. Then four electrodes are connected to an energizer and a main system according to their designation. It means that electrode A should be connected to A in an energizer and so on. Now the step number 7 would be further explained by my friend.
Now I'm going to explain on how to create project file using GEA-RM1 software. So this is the layout of GEA-RM1 software. So to create a project file, first we have to click on new table. So after clicking on new table, this layout will appear. So from here, firstly we have to choose the measure type. So for us, we have to choose the measure type as a menu. And then again we have to choose the method type. There are lots of options here. From among all of them, right now we have to choose A, M and B generic as our method. and then we have to enter the measure number. So a measure number depends on total length and spacing between electrodes. Now to calculate measure numbers, we have general formula, which is equal to total length minus 3 times A divided by A. So here A represents the spacing between electrodes. So if we have to calculate the total measure numbers for the length of 50 meter by keeping spacing between electrodes as 5 meter, 10 meter and 50 meter respectively, then we can calculate the measured numbers as follows. So for the spacing of 5 meter, we can calculate the measure number as n equal to 50. 50 it's a total length minus 3 times 5. So 5 is the spacing between two electrodes divided by 5 plus 1 equal to 8. So here we are getting the measure number as 8. And similar to first one, we can calculate the measure number for the spacing of 10 meter as 5 and 50 minus 3 times 10 divided by 10 plus 1, we are getting measures number as 3. And for spacing of 15 meter, we are getting the measure number equal to 1.33, which is approximately equal to 1. So to find the total number, we have to add these 3 measure numbers. So when we add, we are getting total measure number as a 12, and it shows that it is the total number of measurements to be taken to cover 50 meter. After creating the project file in a computer, then we have to upload it to the main system. Now I will explain on how to record the data in the main system. So firstly, you have to switch on the ERT machine and then upload the file. And then on the main system, there will be many options. So among all of them, we have to select session measures and then press enter. So select the file that has been uploaded from the laptop. And to take the measurement, we have to switch on the tree energizer. After that, we have to select next measure option and press enter. And then select execute and modify option and press enter. Press enter to execute and again press enter to confirm, so that the system will start to record. So after recording, we have to check the sigma value. So if we get sigma value equal to 0, then we have to select the accept measures option and then we have to press enter. So if we get sigma value greater than 0, then it indicates that there is some error in our setup. After that, after accepting the measure, the data for first measure will be recorded in the main system. So to record or to collect the next data for next measure, we have to switch off the tree energizer and then we have to shift the electrodes to next position. So after that, then to get the data for next measures, repeat the step from step number 5 to step number 10 till we reach the required measurement number.
Now I will give the data analysis of ERT. Before directly moving into the data analysis of ERT, we will just look how the data is downloaded from the main system of ERT machine. So we will just look into the overview of how our laptop gives when it is connected with the ERT and after opening the software. So if our laptop is connected with the ERT machine, this both dialog box will be active. Just now it is not connected and it is inactive. So before we have given the table we have uploaded table using the upload button, and now we need to download that table using this download button. So we will just click on this download button, and then such kind of dialog box will be displayed. So from the dialog box displayed, we need to choose our file that we have uploaded before. So just now we have to tick the PE2Geo. We have given the table name as PE2Geo, and we need to tick here, and after that you need to download. So if your download is successful, such kind of download dialog box will be displayed, and it says download successfully done. So after that, then we need to save that data into a file that is easily accessible. So just now we have, when we open our downloaded file, such kind of table will be displayed. So from this table, it gives information of how we have inserted our table or uploaded our table in the ERT main system. So after downloading the table, we get this parameter R. So the only parameter that we use is R, so that is resistance. So to calculate the resistivity, we need R. So after that, we need to calculate the resistivity by using the R with reference from the table that we downloaded. Now to insert our data in a data analysis software, manually we have to create our data by using the Notepad. So the file extension that is accepted by the data analysis software is .dat format. Now we have to create the data in such a way that by using the format. So just now we are using the Vienna array data file format, so we need to follow this format to insert the data. So firstly, it says that the name of the survey line, so we have kept as B2EG, and then the unit electrode spacing that we have kept is 5 meter. Unit electrode spacing is 5 meter, and then array type, so it is 1 for Vienna, so we have given the 1, and number of data point is 12, so that we have already calculated that for unit spacing of 5 meter we have calculated 8 data points, and for 10 meter we have got 3 data points, and for 15 meter we have got 1 data point, so total 12 for the length of 50 meter. So now we will give the type of X location for data points, 1 for midpoint. Just now we are following the midpoint, so we will give 1, and we assume that there is no IP data, and we will give the value as 0. So to calculate the resistivity, this resistivity, and this is the midpoint, and this is the unit electrode spacing. So to calculate resistivity, we need to just use this formula. So A is the unit spacing, R is the resistance that we have obtained. By using this table, we need to calculate the resistivity. So this is the R value, and we need to just give into this formula and calculate the resistivity. So how we have obtained 7.5 is that firstly we have kept the unit spacing of 5 meter between each electrode A, M and B, and the center point for this M and N is 2.5, so it is the midpoint of this A, M and N electrode. So by adding 5 plus 2.5 we will get 7.5, and this is the unit electrode spacing, and this is the resistivity for the first point. And now we will just add this 7.5 with the unit spacing, and we will get 12.5. So it is also 5 meter unit spacing, and we will go until it is reached to 8 points. So for 5 meter spacing we have got 8 data points. So after that, the same procedure is followed for the 10 unit spacing and 15 unit spacing. And then lastly we need to give this 000 for this type of method. And these are all the resistivity that we have calculated by using this table will explain how data is inserted in a data analysis software. So the name of the software is RES2D inversion 64-bit. So we will just open. So we have no license and we need to cancel it. Okay. Now we need to insert the dat format file in this. And firstly we will read the data file. So we have kept it as ert.dat. This is the notepad format in the file with the file extension dat. We will open it. Okay. So we will just do the inversion. So carry out the inversion. So we will save it as ert1. So the final interpretation of the ERT test is this map. So from this we can interpret the subsurface ground profile,
And this is the pictorial representation of the ground material, and based on the resistivity we can determine the types of material present under the ground. So for example, if there is presence of water, the resistivity shown will be very low since being a good conductor, and if there is presence of bedrock, the resistivity shown will be very high. So this is the end of our presentation, and thank you.